Good day to you. This is teacher Leland, Alejandro, and we're going to discuss today parallel lines with transversals. Now, parallel lines are lines that have the same slopes, and these are supposed to be contained in a single plane. Now, a transversal is a line which intersects lines at different points. So, we're going to study the individual angle pairs that are considered under parallel lines with transversals. So we're going to see the problem set first over here. Okay, here's the first number, but we can actually see the entire set. Okay, this is the entire set. Okay, and you can see here the number of problems that we're going to discuss. So we have here about, let's see how many. Okay, we have here about 6. Let's see how many. 8. This is about 18 numbers. Okay, up to the second page. Okay, 18. All right, let's start with the first number. We are going to use the presentation view here. Okay, here's the instruction. Find the measure of the angle indicated in bold. All right, so bold letters, it's the darker one. Okay, here. All right, so we're after this angle. Now, the symbols, the red symbols that you see indicates parallel lines. So these two lines here are supposed to be parallel. Now, the very nature of this angle pair, this is actually called corresponding angles. So we shall try to solve the required. Okay, so let's have the solution for this. Okay, so corresponding angles are supposed to be congruent if they're contained in parallel lines, okay? And the very definition of this is actually if two parallel lines is cut by a transversal, okay, then corresponding angles are congruent. So this angle and this angle are supposed to be called corresponding angle pair. They can only be congruent or equal in measure, okay, if these are from parallel lines with a transversal, okay, from two parallel lines with a transversal, cut by a transversal. Now, they can only be equal if the lines are parallel. And what else? The definition of corresponding angles, these are two angles or an angle pair. One is exterior and one is interior, okay, on the same side of the transversal. It's like that. Okay, so if we will do another diagram, this is the transversal and these are the two parallel lines. Okay, this and this are the corresponding angles. So the very definition of this, one exterior and one interior on the same side of the transversal. So that will be the definition for corresponding angles. Now going back to the problem, they're supposed to be equal in measure, okay? Equal in measure. So that this is equal to this. And we have the equation. We have 6x plus 13. That should be equated to 8x minus 1 there. So we have a working equation here and we're supposed to solve for x. So we will solve for x and then use the x in here, because that's the indicated bold letters, okay, the darker one, all right? And then we'll be able to have the measure of that angle. All right, so we solve this equation, minus 6x minus 6x. You'll have 2x here, minus 1. This is 0, this is 13. And so we add 1 here, and add 1 on the other side. This gives us 14. This is 2x. And dividing both sides by the number 2, x is equal to 7. There. So we have the value of x. We can now use x in the expression 8x minus 1. So we have here 8x minus 1. We're going to use the 7. So 8 times 7 minus 1 gives 56 minus 1. We have 55. So the measure of the angle indicated in bold letters is 55 degrees. There. And we can verify that. There. You can see it over here. So in red numbers, the angle required is 55 degrees. So we're correct. It's over here. And that's it for the first number. We shall continue with the second. Let's have the second. Here's the second. Find the measure of the angle indicated in bold letters. All right. This is another set of corresponding angles. So this is another pair, angle pair. And we can see the angle pairs corresponding angles. Okay. By definition, this and this are supposed to be congruent or equal in measures, because the symbol, the red symbols, means the two lines there are parallel. So we have, again, the working equation here is the angle represented by 29x plus 3 is equal to 31x minus 3. There. Corresponding angles are equal. So we're going to solve for x here and then use this x value in the bold letters, okay, that we see there, okay, or the expression in bold letters. All right, that represents algebraically the measure of the angle. So we will solve this by, all right, by subtraction 29x minus 29x. This is now 0. We have 3 at the left side. 31x minus 29x, that should be about 2x. We still have the minus 3 at the right side. Okay, isolating the numbers from the letters, we add 3 to both sides. There. And we will have 6 at the left side of the equation. This cancels out to 0. We have just 2x on the right side. So we're down to this equation, 2x equals 6. So we will just divide by the 2. And x is equal to 3. Or properly written, it should be x equals 3. Okay, the x is not the required. We're after the value of this angle here. The angle indicated in darker letters. All right, so we have to use the 29x plus 3. And we shall use the 3 now. So 29 times 3 plus 3. So we have here something like 87 plus 3. That should be 27 carried to 87 plus 3. We have 90. Okay, so the answer for the angle is 90. We shall check and verify. And there you can see the red number, 90 degrees there. And so this is correct. All right, let's have our third example. Let me clear the screen. I hope you were able to get the solution. Okay, remember the corresponding angle pair, okay, they are equal in measure for as long as you have this line and this line parallel. Only when they are parallel, okay? All right, don't forget that. All right, let's continue with the next. Let's do number 3. Okay, here's number 3. And we can see this is another angle pair, corresponding angle pair again. This is an exterior, this is an interior, and these are two angles on the same side of the transversal. Okay. All right. So to give you an idea what corresponding angles are, if you have parallel lines, okay, with a transversal, let's put numbers 1, 2, 3, 4, 5, 6, 7, 8. Okay. This angle and this angle That's an angle pair called corresponding angles, 1 and 5. Also 2 and 6, another pair of corresponding angles. Also 3 and 7, that's another corresponding angle pair. And we have the 4 and the 8, another pair of corresponding angle pair. Okay, you can see angle 1, angle 2, angle 7, angle 8. These are called external or exterior angles. Okay, and then the remaining angles 3, 4, 5, 6 are called interior angles. So the definition of corresponding: one exterior, one interior on the same side of the transversal. Okay, so it's like this: one exterior, one interior on the same side of the transversal, just on one side. Okay, so that's the very definition of corresponding. Okay, so that's it. We shall continue with the solution. I will just erase this. Okay, I'll just erase. All right, let me just erase there. Okay, so the corresponding angle pair is supposed to be equal in measure. So we have the equation 8x plus 14 is equal to 9x plus 2. And then this is our working equation. So for x first, minus the smaller 8x to both sides is 0. We have 14 at the left. 9x minus 8x is 1x, or simply x. You still have the plus 2. Isolating letters from numbers, we subtract the 2 here. Subtract the 2 here. We have a 12 at the left side. This is now 0. We have x. And there we have the value of x is 12. Okay, so x is equal to 12. Now, again, we're not after the x here. We will only use the x for finding the value of the angle indicated in bold letters. All right, and the bold letters here is actually the 9x plus 2. Here, this expression will give us the measure of that particular angle. So we have 9 times 12 plus 2, and that gives us 108 plus 2, giving us 110. So our answer must be 110 degrees. Okay, let's verify and check. There. According to the computer, it's 110 degrees in red numbers. All right, so we're done with our third example. Let's continue with the fourth. Okay, let's have the fourth example. Okay, here's the fourth example. Let's examine the type of angle pair. Now, this looks like another type of angle pair. Okay, these are two interior angles on opposite side of the transversal, and this is called alternate interior angles. So this is called alternate interior angles. There, alternate interior angles. It's an angle pair, both angles interior angles on different sides of the transversal. Okay, so this is what you call alternate interior angles. All right. Now, if parallel lines have a transversal only when they are parallel, okay, then alternate interior angles are congruent. The two angles are equal in measure, okay, only when you have parallel lines. All right, so we have our working equation. Let's proceed to the working equation. All right, that means this angle is equal to this angle, okay, when you have parallel lines. That means our working equation is 22x plus 4 equals 24x minus 2. And we're going to solve for x first, and then we will find the value of the angle indicated in bold letters. All right, so we shall solve this first. We shall try to subtract the smaller x term. And so this is 0, this is 4. This gives us 24x minus 22x is 2x minus 2. So we add 2 to both sides. And this is 6 equals 2x. We divide 2x by 2 and by 2. The other side also, x happens to be 3. There. And x equals 3. Okay, we shall now use the value of x to solve for the angle. All right. The algebraic expression for the angle is 24x minus 2. We shall now use the 3 here. 24 times 3 minus 2. And this gives us 72 minus 2. And our value is 70 degrees. There. That's our answer. All right, let's check and verify. We have 70, okay? Correct. Our answer is 70. It's correct. There. Okay, that's number 4. Let's have number 5. Number 5. All right. Find the measure of the angle. Okay, let's see what type of pair we have. It looks like another alternate interior angle pair. So that means we have parallel lines and a transversal. This angle must be equal to this angle. And we have our working equation. 1 plus 7x equals 6x plus 8. We solve for x first. Minus 6x minus 6x. We have x plus 1. This is equal to 8. Okay. And we shall isolate the letter from the numbers. This is minus 1 and minus 1. X happens to be 7. Knowing the value of x equal to 7, we can now solve for the angle indicated in bold letters. That is 1 plus 7x. And we have 1 plus 7 times the 7. This gives us 1 plus 49. And we have 50. There. Our answer must be 50 degrees. Okay, let's check and verify. All right, over here, we have the red numbers showing us the correct answer. There. And we're done with number 5. Let's continue with the next number. This is our example of alternate interior angle pair. All right, so let's continue with number 6. Let's have number 6. Here's number 6. We can recognize again that this is just another alternate interior angle pair. And again, we have this parallel to this line. That means this angle is equal in measure to this angle. We can now have our equation. 8x minus 6 must be equal to 6x plus 12. And we can solve for x. All right, we shall start by subtracting the smaller 6x to both sides. This zeroes out. We have here just 12. The left side will give us 2x minus 6. And we shall isolate the letter terms of or from the numbers. All right. So we add 6 here, add 6 here. And we will have 2x equals 18. And we shall get the x by way of division. Divide by 2. X is 9. There. Okay. Knowing x equals 9, we can now solve for the angle indicated in bold letters. That should be 8x minus 6. We have 8 times 9 minus 6. We have 72 minus 6. That looks like 66. 66 degrees. And so we can verify that. There. Looks like our answer is correct. 66 degrees. Okay, this is how to solve for angles expressed in algebraic equations or algebraic expressions. All right, that's it for number 6. Let's continue with the next number. Here is number 7. Okay. All right. Watch the figure carefully. We have parallel lines, and then these are the angles. Okay. This is another type. Okay. The two angles are on opposite sides of the transversal, and they are both exterior. Exterior. So this is called alternate exterior angle pair. So this is alternate exterior angle pair. Okay, alternate exterior. So these are both exterior angles on opposite side of the transversal. All right, so what about this alternate exterior angles? If parallel lines have a transversal, then alternate exterior angles are congruent, meaning they have the same measure also. So we can have the equation. We can have 15x plus 5 equals 16x. There. And we can solve for x and then solve for this angle here. Okay, so we will subtract the smaller term with x. And we have 5 at the left side. And 16x minus 15x is x. And x happens to be 5. There. But we are not after x. We are after the value of 15x plus 5. Okay, the angle indicated in bold. Measure of the angle indicated in bold letters. So we will now use the 15x plus 5. Use the x value here. So this is 15 times 5 plus 5. And this is 75 plus 5, giving us 80 degrees. There. And that's our answer. Okay, and we shall verify. There, you can see the red numbers over here at the left side of the screen. That's the confirmation that our answer here is the right answer. All right, so that's the way to solve problems like this. If you have expressions of the angles in algebraic expressions, you will have to see how you can equate them or find the equation first, and then solve for x, and then use the x where it should be used. All right, so let's proceed to number 8. Let's have number 8. Okay, here's number 8. So we have parallel lines again, okay, based on the red symbols. And the two angles we can see labeled with the algebraic expressions, it looks like a pair, which is like the number 7, alternate exterior. So this must be an exterior angle, and this is another exterior angle on opposite side of the transversal. And so they're congruent when when the transversal is intersecting parallel lines. So we have the equation 5x minus 5 equals 3x plus 17. So all we need to do is solve for x and then use it in 5x minus 5. Okay, 5x minus 5. So we can set that ready, because this is the expression in bold letters and numbers. All right. Solve for x first. All right. We shall subtract the 3x to both sides. Left side gives 2x minus 5. Right side will just be 17 because this is 0. Yeah. All right. Isolate the letter terms with the number terms. All right. So this will be plus 5 plus 5. We have here 22, and this is 2x. And just one more step, divide by the number 2. The number beside the variable x is 11. Okay, now we're ready to use the 5x minus 5. This will be 5 times 11 minus the 5, which gives us 55 minus 5. Answer should be 50 degrees. There. And so let's verify. Okay, we have here the 50 degrees at the left side of the screen. There. Okay. So we're correct. And we shall continue with the next example, number 9. Let me clear the screen and continue with number 9. All right, here's number 9. You try to investigate the diagram, okay? And it's clearly like another exterior angle pair, okay? Or alternate exterior angle pair. And this is parallel to this, and this is the transversal. We have this angle exterior, and this another exterior. So the two angles are in opposite side of the transversal, both exterior. And so they're supposed to be equal in measure. 30x must be equal to 31x minus 4. And we shall solve this by subtracting the smaller 30x. And so the left side is 0. We have here 31x minus 30x is 1x, or simply x, minus 4. All right, isolate the number from the letter. Add 4 and add 4. Left side is 4. Right side will just be the x, and x is 4. Okay, determine now the required angle 30x. That's the angle indicated in bold letters and numbers. All right, 30 times 4. This must be about 120 degrees. And so we can verify that from our computer there. And we have the confirmation. All right, 120. All right, so that's the required measure for the angle. All right, let's have the next, number 10. Here's number 10. Okay, now we have another pair, different pair. Okay, what do we call these two pairs? All right, this is supposed to be two interior angles on the same side, of the transversal. If you have parallel lines, if parallel lines have a transversal, then the two interior angles on the same side are supplementary. Okay, supplementary. Okay, two interior angles on the same side of the transversal are supplementary. Okay, meaning the sum is 180. Okay, only when the lines are parallel. Okay, so again, if parallel lines have a transversal, okay, then interior angles on the same side of the transversal are supplementary. Okay, all right, supplementary means the total is 180. That means this angle plus this angle, when added, equals 180. So our working equation will be this way: x plus 88 plus x plus 104. This must be equal to 180. So again, if parallel lines have a transversal, then interior angles on the same side of the transversal are supplementary. Okay, all right. So we can now solve this. Okay, so we shall try to combine the two x letters. 1x plus 1x, we have 2x. We have 88 plus 104. Okay, so that should be 104, add 88. Okay, this is 12, carry 1, you have 9. You have 192 for the numbers there. So we combine the x, and then we combine the 88 and the 104. We have 192. And that equates to 180. All right, next step. Isolate the terms with letter from the numbers. So we shall subtract the 192 and subtract 192. There. This zeroes out. We will only have 2x. The right side will be 180 minus 192. Your subtrahend is larger, so we will have a negative. And the difference is 12. Okay, so that's a negative 12 there. Okay, now next step is to divide by 2 both sides of the equation, and x is negative 6 there. And so we shall now solve for the angle or measure of the angle indicated in bold writings, x plus 88. We shall remove our writings over here, so we have something to write on. All right, there. Okay. And then we put here the required expression, x plus 88. Okay, our x is negative 6, so we shall have negative 6 added to 88. And that should be about 82 degrees there. Okay, so we shall verify. All right. Why did we use x plus 88? Well, this one is darker. Okay, so x plus 88 is darker. It's clearly darker. Okay, so we're supposed to find the measure of the angle indicated in bold. All right, so x plus 88 is used. We will combine negative 6 and 88. That is 82. All right, let's verify. Here's the answer. You can see it at the left side there. It's 82 degrees, confirming our 82 degrees correct. So that's number 10. Let's continue. Let me go to number 11. All right. Let's continue with number 11. All right. So this must be... All right. That's 82 degrees. Let me remove the answer first. Okay. Let's continue with number 11. Here's number 11. Find the measure of the angle indicated in bold. Okay. This looks like another pair on the same side of the transversal, and they're both interior, and the two lines are parallel, then these two angles must be supplementary. So meaning to say we can add 11x plus 15. We can add this to 7x plus 3. Okay, and this must be equal to 180. 11x plus 15 plus 7x plus 3 equals 180. Okay, so we shall solve for x here. We have 11x and 7x. This is 18x. And then that is by adding these two terms. Now we shall add the 15 and the 3, which gives us positive 18. And this is equal to 180 there. Okay, subtracting now the 18. Subtracting the 18, this is 18x. This is equal to, this is 2, this is 7. That's 162, okay? All right, by dividing this by the 18, we divide by 18 both sides of the equation. X must be about 9, okay? That looks like 9. Yes, x equals 9. All right, so x equals 9 can now be used in the expression 11x plus 15. This is the required there. So this is now 11x plus 15. So we have 11 times 9 plus 15. And we have 99 plus 15. So this will be something like, how much is that? 114. That 114. 14 carry 1. That looks like 114. 114 degrees. All right, let's check and verify. 114, yes, it's correct. It's over here. 114. And that goes to our number 11. We shall continue with number 12. I hope you're learning the differences between corresponding angle pair, alternate interior, alternate exterior, and this kind of pair supplementary. Okay. All right. Let's continue with number 12. All right. Let's clear the board. All right. Here's number 12. Okay. Here's number 12. We have another parallel line set with a transversal, and we have two angles interior on the same side. So when lines are parallel with a transversal, the two interior on one side are supplementary. So that means when you combine the measure of this and this, that should be 180 supplementary, okay? Means 180. So we have our working equation 17x minus 1 plus negative 2 plus 44x equals 180. There. Okay, so we can combine this right away. The negative 1 added to negative 2, that's negative 3. We can also combine the 44x and the 17x. That should be about 61x, okay? There. Yes, 61x. And then this is equal to 180. So we add 3 here, and we add 3 here. So this is 183. That equates to 61x there. Okay, so 61x equals 183. We will be having a division here by the 61. Divide by 61, and x looks like exactly 3 there. And we now have the value of x. Now we're up to solving the angle with darker letters and numbers. 17x minus 1, okay? And then this will now be 17 times 3 minus 1. So we have 51 minus 1. We have 50 degrees there. Okay? All right, so that's our number 12. Let's see and verify. The answer is 50 there. And we are correct. All right, so that goes to our number 12. Let's proceed to number 13. Okay, number 13. Check and verify, check and verify. Here's number 13. Okay, what kind of pair is this? Okay, what kind of angle pair is this? All right, you have two intersecting lines. The angle pair is actually formed by two intersecting lines, okay? This line and this line, this and this, okay? That's our angle pair. So this is actually called a vertical angle pair, okay? So what is the definition of vertical angles? Vertical angles. Okay, what are vertical angles? Okay, two angles non-adjacent. They are non-adjacent angles formed by two intersecting lines. Okay, so this is the definition of vertical angle pair. And you can see it from our example. And by definition, vertical angles are always congruent. That means equal in measure, okay? If you have two lines like this measure must be equal to this measure, okay? Vertical angles are always equal in measure. All right, so we have our working equation. 13x plus 1 equals 14x minus 7. All right, we shall write the equation. Let me just remove my drawing. All right, we have the 13x plus 1 must be equal to 14x minus 7. There. And so we solve for x and then solve the measure of the angle indicated in bold letters. All right, so we shall start by subtracting 13x, and this is now 0. This is 1. 14x minus 13x, that's 1x, and then we have the minus 7. Okay, next step is to isolate the letter from numbers by addition. Add 7 here, add 7 here. And we have right side x, left side 8. Value of x is 8. All right, and we write it this way, x equals 8. Okay, we don't write 8 equals x. We usually put the letter at the left side. All right, so knowing x equals 8, we shall now solve for the required. We shall use 13x plus 1. Okay, these are the expression in bold letters. All right, 13 times x means 13 times 8 plus 1. This is 60. How much is that? That looks like 24 carry 2. That's 104. That's 24, and then carry 2. That looks like 8 plus 2. We have 104 plus 1. That's 105 degrees. 105 degrees there. And let's see the answer. Computer. All right, it's 105 degrees over here. Red numbers there. 105. So this is correct. And that's it for vertical angles. And we have our first example. Let us see the other examples. All right, let's have number 14. Let's see number 14. Okay, just another vertical angle pair. This and this is a vertical angle pair. They are supposed to be congruent. Vertical angles are congruent, okay? So we have the equation 19x plus 2 must be equal to 20x minus 5. So we solve for x here and then use the x in 19x plus 2. That's the darker one, okay? So we will use that later. All right, let's solve first. Minus the smaller 19x minus 19x to both sides. This zeroes out, and okay, this will zero out, and we have just 2 at the left side. All right, 20x minus 19x is 1x, or simply x, but we still have the minus 5 over here. Okay, so we will continue with the minus 5 on the next line. Okay, one more step, and we have the value of x. That will be by way of adding 5 here and adding 5 here. X happens to be 7 there. And again, we will have to write it letter first there. And we have x equals 7. We can now solve for the required angle. Okay, 19x plus 2. That looks like more than 19, okay? By looking at the diagram, that looks like an obtuse angle. So let's see if it's really an obtuse angle. 19 times 7 plus 2. So this is 63, carry 6. That's 133. Plus 2, that looks like 135. There, 135 degrees, okay? 135 degrees. All right, let's check and verify. 135, yes. 135 degrees. Okay, that means our computation is correct. Okay, and that's the answer for number 14. Next number is 15. I hope you're learning the process. Let's continue with the next number. Okay, let's have number 15. All right, here's number 15. Okay, by looking at the diagram, it looks like another vertical angle pair. And this angle must be equal to this angle. Again, definition of vertical angles. This is an angle pair, two angles non-adjacent formed by two intersecting lines. Okay, so that's the definition. Two angles non-adjacent angle pair formed by two intersecting lines. Okay, so That will be the definition of vertical angles. So we have the working equation. That's 10x plus 10, and this is equal to 11x plus 1. There. Okay, so we subtract 10x to both sides, and this is 10. This is equal to 11x minus 10x is 1x, or simply x, plus 1. And then we subtract 1 from both sides, and this is 9 equal to x, or we appropriately write it x equals 9. Okay, so now for the required. The required, of course, is the one over here. Okay, 11x plus 1. Okay, remember, the instruction is find the measure of the angle indicated in bold. Okay, so the darker numbers and letters will be the expression that we're going to use, and that's 11x plus 1. Okay, and so we have now the x. This is just 1, 1, that's 11 times 9 plus 1. So this is 99 plus 1 gives 100. 100 degrees must be the answer. All right, we will verify it over here. There, it's 100, and this is the correct answer. Okay, let's have more. Let's continue with 16. Let's have number 16. Okay, let's proceed to number 16. Okay, what about this? This doesn't look like vertical angle pair, all right? Now, this is a linear pair, okay? A linear pair, okay? All right, so a linear pair is a pair of angles. They are adjacent to each other. They share a common side, a common vertex, and the total is 180. And the two non-common sides are opposite rays, okay? Opposite rays. All right, so what do we mean by that? They form a straight line there. But this is adjacent angle pair. An adjacent angle pair, two angles sharing a common side and a common vertex with no overlapping interior points. Okay, so the two rays form opposite rays, oppositely directed rays, forming a straight line. Okay, that's why it's called linear pair. It is called linear pair. Pair. And a linear pair is supposed to be supplementary. The total of this and this is 180 degrees. Okay, so this is what you call a linear pair. Remember, the sum, this added to this, equals 180, half circle. Okay, all right, so this is 180. If you go around it, that's another 180, making it 360. Okay, so this is 180 degrees total. Okay, all right, so much for the definition. Let us solve for the angle. All right, let me clear my writings here. Let me just clear it. All right, just remember the name. The name is linear pair. Okay, because the non-opposite rays form a straight line. Okay, that's why it's called linear pair. All right, so how about our equation? Since these two angles are supplementary, the total is 180. Okay, so we can now add 9x minus 12. That represents the first angle. Add the 7x. Okay, the sum must be 180. There. All right, and so here's our working equation. Solve for x first. Okay, so we shall solve for x first. We will combine 9x and the 7x. That gives 16x. Okay, we still have the minus 12 over there. And then this is equal to 180. All right, add the 12 to both sides. So add the 12 to both sides. All right, add 12. This zeroes out the 12 and the negative 12. Okay, this one, and we will only have 16x. Okay, and the right side is 192. There. Okay, what about the next step? Next step is division. We shall divide by the 16. So we will get the x. There. And x is equal to something like 12. Is that 12? Looks like 12. 19 by 16, we have 1, and then difference is 3, bring down 2. 32 divided by 16, that's 2. We can verify that. 12 times 16 must be 192. 16 times 12, let's see if it's correct. 2 times 16 is 32. We have 6. We're doing multiplication here. 192. Yes, it's correct. That means x equals 12. Yeah. I verified it by multiplication. All right, so let me erase my multiplication there. Okay, let's continue with the required answer. We're asked to get the 9x minus 12. 9x minus 12. Okay, this is 9 times 12 here, minus 12. So we have here like 108 minus 12. Okay, we deduct the 12 here, and we have like 96. Is that so? Is that equal? 12, 18, carry 108. 9 minus 2. 8 minus 2 is 6. 10 minus 1 is 96. All right, it looks like 96. All right, let's verify it. I got 196. I got 96 degrees. Okay, 96 degrees. 108 minus 12. All right, so let's verify. Yes, it's correct. 96 degrees. All right, so that goes to our answer. Let's have our next two numbers. Let's have number 17. Okay, let's have our next number. Here's number 17. Here's another linear pair. Okay, obviously we have a straight line here. There's the straight line, and this is the common side. Okay, this plus this equals 180. All right, so it's a matter of recognizing the diagram, what type of angle pair. So we have here 12x plus 10. We will add the other supplement, that's 4x plus 10. Their sum is 180. Yeah. Okay, solve for x first. So we combine 12x and the 4x, that should be about 16x. We shall combine the 10 and the 10. That gives 20. And this equates to 180. All right, next step, isolate the term with a letter from the numbers. We shall do that by subtracting the 20. And we will get 160 at the right side. And this zeroes out, of course, and we shall just get 16x. Okay, this looks like 10, okay, by dividing it by 16, but let us do it first. Divide by 16, divide by 16. 160 by 16 is 10. There. And that's only the value of x. We're not after the x. All right, we need the angle, which is the measure of the angle indicated in bold, and that's 12x plus 10. There, and so we substitute the 10 here, plus 10, and this is 120 plus 10, that looks like 130 degrees. There, and the answer must be 130. That's 130. There. All right, that goes to our number 17. Let's have the last number, number 18. I'm sure it's the last number. We look at the problem set in the beginning. All right, so Let's continue with the last number. All right, let me erase the screen. Okay, let's continue. Here is the last number, number 18. So it's another linear pair, okay? Linear pair. We have a straight line. This is the common side. This plus this equals 180. They are supplementary. Our working equation is x plus 106 plus the other angle is 86 plus x. And that equates to 180. All right, let's solve. X plus x is 2x. And then we add 106 and 86. So let's show that. 106 plus 86, that's 12, carry 1, 9, 192. And this is equal to 180. Okay, so we deduct the 192 to isolate the term with a letter. And this is also minus 192. This zeroes out, we only have 2x. And we have 180 minus 192. Our subtrahend is larger, so we'll have a negative. And that's a negative 12. And by way of division, we shall get the x. X is negative 6. There. And then we shall solve the required angle. We shall remove the scratch there. All right, let's continue. Okay, we're after the measure the angle indicated in bold letters. We shall have x plus 106, x plus 106. The x happens to be a negative 6 plus 106. That clearly is 100 degrees there. And we shall check and verify. All right, it's 100 degrees there. And that's the answer, okay? All right, so I hope you were able to learn from these 18 examples with different angle pairs involving parallel lines cut by a transversal. So this will be all for this discussion. See you later and bye-bye.